Hello Year 8s, this is lesson 12 in the Forces, Waves and Generating Electricity booklet. The final two lessons we will look at an investigation into the surface area of a solar cell and the current that it generates. First off, let's just have a look at a quick video on this subject. So we have here an experiment involving a lamp, a solar cell and a multimeter that is going to measure current. What we're going to do is this. The lamp is going to be 8 centimeters away from the solar cell. The solar cell is going to provide us with a current reading. The current reading is measured using our multimeter, and notice that the dial is at the 3 o'clock mark right there. It's giving us milliamps, and at the moment it's 4.17 milliamps, and 100% of the solar cell is exposed. Now I believe that to be 9 centimeters by 6 centimeters, so that is 54 centimeters squared is its surface area. What we're going to do now is we're going to take a piece of card and we are going to put that over sections of the solar cell. So if I put the card here like so, we have covered 6 centimeters squared because it's 1 centimeter wide by 6 centimeters long. So we now have 54 centimeters squared. Take away 6, which is 48 centimeters squared, and now we are getting a new reading. And we keep on going. We move 1 centimeter along every time, but in essence that is 6 centimeters squared less every time we move the card along. And so as I move the card along, you should see that the current reading goes down. Once all of the solar cell is covered by the card, it will not surprise you to find out that the reading turns to 0. You will be collecting your results. So just to recap, this is our solar cell right there, and light from the lamp is going to come down and cause it to generate a current which can be read using the current reader in milliamps. However, what we are going to do is we are going to move this piece of cardboard here over the solar cell. So there's less and less and less of the solar cell available to convert light from the lamp into electricity. This could be your prediction. As more of the solar cell is covered by cardboard, less light energy reaches the solar cell, and so less electricity is generated. Now you could go beyond that, could you try and provide a number link as we half the amount of solar cell that can take in light energy, will that half the amount of current generated? You could do that. That's a lovely number link. So, before we move on to our method and a results table and a conclusion, I've missed out on the independent, dependent, and control variables. I wonder if you can't come up with these now. I'm going to pause the computer screen for a second. Let's see if you get the right answers. Okay, the independent variable, the thing that we will change, surface area of solar cell, and that is going to be in centimeters squared. What's the dependent variable? What's going to change as a result? It's going to be the current reading. It's the amount of electricity. And if you remember, it was in milliamps. Now, a control variable, what did we have to make sure we kept the same? It was the distance between the lamp and solar cell. Can you remember what it was? We kept it at 8 centimeters, if you remember. So, there's the variables. Let's go back now. And I'm actually going to let's go back to the method, right? If you've got a completely free solar cell, 9 times 6 is 54. If you were to cover 1 centimetre by 6 centimetres, then you're reducing the surface area of the solar cell. So the surface area of the solar cell in centimetres squared started up at 54. It then went down by 6 because you've covered that up with the cardboard. So it's gone down to 48. If you cover up another centimetre this way, then you reduce the surface area of the solar cell by yet another 6 centimetres squared. So it's gone from 54 down to 48, down to 42, then it will go down to 36. That will be this. All of that is covered up. And then we go down to 30. Do you see how it works? And then we're going to keep on going down in 6s all the way down to 0. And at 0, the whole thing, all of it, will be covered up with the cardboard. I hope that makes sense now. Let's go through the method. Place a 9 centimetre by 6 centimetre solar cell on a table. 8 centimetres away, place a lamp. Attach a current reader in milliamps to the solar cell. Turn on the current reader in milliamps. for the solar cell with a surface of 9 times 6, which is 54 centimeters squared. Using a 9 centimeter by 6 centimeter black cardboard, cover the solar cell by 6 centimeters squared. So you are reducing the surface area of the solar cell. It was at 54 centimeters squared. It's now gone down to 48. Move and take a current reading in milliamps. Keep moving the cardboard so that a reading for the current reader is taken with a reduced surface area of 6 centimeters squared. The range of surface area goes from 0 to 54 centimeters squared. The interval, what it goes down in every time, equals 6 centimeters squared. Record your results in a results table. That is the end of lesson 12.